I'll be honest, I can't believe you came back after that last video, but I'm glad you're here. Today, we're doing radical functions with some transformations. Now, radical functions are the inverse functions to like x squared and the square root of x. Those are inverse functions. But we're not going to include the complex number system. So when we see the graphs of, if you look at the blue here is x squared. If you do the inverse of it, it's like you switch the x and y coordinates, so that would turn that parabola sideways. But when you take the square root of 1, we're only going to count it as positive 1. So really, we're only going to, with the square root functions, let's see if this will write. Here we go. We're only going to take the top half of the parabola, because if it was a function, it would have to pass the vertical line test, which means you cannot have 2 points in the same vertical line. So we're only going to take the top portion of the graph for the square root. So all our square root functions, that's what the parent function is going to look like, which we'll see here in a second. Cube root, that's all over the place. So if you had a cube function, that's this blue line. So like this would be x cubed. If you inverse that, you switch the x and y coordinates, that becomes this like flat S almost. So cube roots can include all positive and all negative numbers. Square roots are only going to include the positive versions here. So let's try out, let's graph the function, just the parent function, f of x equals the square root of x. So again, we're not going to include the negative numbers because we're not square rooting negatives. But like, let's pick numbers that we can square root, like 0. What is the square root of 0? 0. So that coordinate, if we chose 0 for x, the square root of x would be 0. So there's a point right there at 0, 0. What's another number that you can square root? 1. If you put in 1 for x, the square root of 1 is 1. So there's going to be a point at 1. Another number you can square root is 4. So if we put in 4 for x, what's the square root of 4? 2. So we'll have a point at 4, 2. The only other number that'll fit on this graph that is a perfect square is 9. And the square root of 9 is 3. So 9, 3. So this shows our graph. Now we have to include the domain and range in this conversation. Remember, domain is like, are there any limits on your x values? All right, I need to stop moving. Hey, no hands. Okay. What is this witchcraft? Okay. So, is there anything x could not equal? Yeah, well, all of our x's start at 0 and go to the right. So the way we write that in interval notation, remember you put a bracket on 0 because 0 is included in that, and it goes on forever to the right towards positive infinity. The range is our y values. Our lowest y value was 0, and then it goes up from there. So it's going to be the same, 0 to positive infinity. And of course, we're going to have transformations with this, which will change the domain and range. All right, now let's take a look at cubes, cube roots. So we're going to think about numbers that you can cube root and have them come out to a whole number. I don't know what's going on. It's the end of the day, so maybe everyone's trying to attach their phone on the Wi-Fi and go, "Hey guys, I'm leaving school. Pretty cool, huh?" I don't know. All right, so a perfect cube would be like 0. So if you cube root 0, you get 0. Another perfect cube, 1 to the third power is 1. So we could say, if you put in 1, you will get out 1. 2 to the third power is 8. So the cube root of 8 would be 2. So 8, 2 looks like this. So that looks very similar to the square root. But you can cube root negative numbers. We couldn't square root them. So we can also include negative 1. The cube root of negative 1 is negative 1. The cube root of negative 8 is negative 2. Now there's no limit to the right or left, so that would be all real numbers. There's no limit up and down. So both the domain and range will be all real numbers. And you write that as negative infinity to positive infinity. All right. Do we have more down here? Oh yeah. Oh yeah. Let's see how far we can scoot down. Oh yeah. This is going to be a 20-minute video for 10 minutes of material. Given the graph f of x equals 4 times the cube root of x plus 4, answer the following questions. What is the parent function? Parent function is just like, what would the starting function be? And this is a cube root function. So we could say parent function would be f of x equals the cube root of x. Now we've done all kinds of transformations in this class. So we have to remember what certain things mean, which it's on the next part of the notes, but let's see if we can remember a little bit. The 4 in the front, that shows you a stretch or compression, vertical. So this is going to be stretched by a factor of 4. We also have the 4 grouped in the cube root with the x, and that is a right and left translation. So that would shift it left 4 units. What would the domain and range be? This is a cube root function. Domain and range for cube root functions is all real numbers. So both of them would be all real numbers. All right. Now here is kind of a sum up of all the different transformations. Now we're really not going to mess with the horizontal stretch and compression. We're going to keep it going with the vertical, which happens outside of the square root or the cube root. So A in front there tells you stretch or compression. If it's grouped in with the x, that is a right and left translation. And then if it's a plus or a minus outside of all that, that's your vertical translation. So the only other transformation is a reflection, and that is if out in front it is a negative, that would flip it completely upside down. So let's try this, the square root of x minus 2. So I'm just going to redraw the graph, the parent function for the square root, which there's a point at 0, 0, 1, 1, 4, 2, and 9, 3. Now, how would this differ from that? It's got the minus 2, but it's outside the root, so that would shift it down 2 units. So just take each of these coordinates, drop it down 2, and there we go. Let's graph B, and then we'll talk the domain and range for both of them at the same time. So this one is 3 times the square root of x. So this one's going to be stretched vertically by a factor of 3. Come on back, Mr. Black. There we go. All right. So again, here's the parent function, 4, 2, 9, 3. We'll do this one in green. So if we took 0 and we square rooted it, it's 0 times 3 would be 0. If we took 1 and square rooted it, the square root of 1 is 1 times 3 is 3. So here's where you see that stretch. It increased it by 3 times as much here. The square root of 4 is 2. 2 times 3 is 6. So there will be a point at 2, 6. And then 9 was our other one. So square root of 9 is 3. And then 3 times 3 would be 9. So here's what it would look like if it was stretched by a factor of 3. Nice. All right. Let's get the domain and range. So while I have the video here, we'll do the domain and range for B. It's the same. It starts at 0, goes to the right, and goes up. So it's the same as the parent function, where it's 0 to positive infinity for both of them. Might be a little different on this one because we shifted everything down 2. Oh goodness, come on. It's just one of those days, you know what I mean? So this one is shifted down 2, but domain is your x values, which our x values still go from 0 to positive infinity. But our y's all drop down 2. So the lowest value is negative 2, and then it goes towards positive infinity from there. How we doing? How we doing? You all right back there? You getting a little sweaty taking these notes? I hear you. I'm getting sweaty here myself. Now we're going to do some matching here. There is a front and back of this. This is just kind of more of an in-class activity, but we'll kind of go with some general stuff. Um, I suppose we can do all of it. I want to make myself smaller. Hey man, do you get small? That's an old Steve Martin bit. I don't know how appropriate that is for school, but all right. So I'd say look for things that jump out at you. So I see that the bottom 3 are all cube root ones, which those are like the S-shaped ones. So like A or H or D. So these 3 are going to match up with 7, 8, 9 for sure. We can knock that out. So like 8, I see it's got a +2 outside of it. That would be shifting it up 2. So between A, D, and H, which one is shifted up 2? H, if you look, goes from 0, 0 to 0, 2. So H is handled. That was this one here. Everything's in the way. Everything. All right. For 9, it's grouped in with the X, so that would be a right or left translation. It says -2. That would shift it to the right 2, which matches up with A. Which leaves us with D for number 7. Now we've got all these square root ones. I'd say, look for ones that jump out at you. Like 5 looks pretty easy. It's the square root of x plus 1, so that would shift it up 1. So we're looking for, there we go, look at F. Everything is just shifted up 1 spot. Let's see, what else do we have here? All right, I guess if we start at number 1, it's 2, so it's going to be stretched vertically, but it has the x plus 3 grouped with it, which would shift it left 3. So I'm going to look for one that's shifted left 3 first. See, E does that. That's it. All right, 1 is E. We're going to come back to 2, and that'll be our last one, and I'll just show you. I mean, it'll be the one that's left over, but it's kind of weird how it makes sense. Now, number 3 has the negative out in front, which flips it upside down, and it is grouped in with a -4, which would shift it to the right 4. So upside down and shift it to the right 4. Ah, see, I see. Oh, yes. All right, so number 4. All right, so it's got the -3 in front. It's got to be upside down, and it's got the -1 after it, which shifts it down 1. So if you look at G, that's shifted down 1, and it's upside down, probably at a rate of 3. So the only other one left would be I, right? Did I use B yet? Oh, whoops, I forgot there's another one still. All right, so G matches up with this one. Now if you look at 6, it's 1/2 the square root of x. So it's going to be compressed vertically. So if you look at option B, you have your parent function here, and then half of that, it's going to smush it down a little bit. So B matches up with this one, which leaves us with I for this. And this is weird because the negative is inside, so it's like the opposite of x. So most of our graphs started at 0 and went to the right because we couldn't square root negatives. But this one is actually going to go to the left because it's going to be like the opposite. Oh, I'm going to scoot down here. Oh my goodness. I want to be able to see that one. So like if you took -4 to put in for x, well, it's saying you take the opposite of x, and then I forget what the rest of the equation was. +2 maybe? minus 2. So if you did the opposite of negative 4, that's 4, right? And the square root of 4 is 2. 2 minus 2 is 0. So there'd be a point at that negative 4, 0. That one's kind of weird. Kind of fun. I don't know. It's kind of fun. All right, let's knock out these matching ones. Again, when I'm doing these kind of problems, I look for the obvious ones first. So, like if you look at options A, E, and C, those are the only ones with a negative leading coefficient, which would reflect it upside down. So I'm looking at the upside down graphs, and our options are 5 is upside down, 4 is upside down, and 6 is upside down. So let's knock those 3 out real quick. A is negative, so reflected, and it's got the plus 1 grouped with it, which would shift it left 1. So 6 is shifted right 1. That one's out. 4 is shifted left 1. And 5 is shifted up 1. So 4 is going to be our A. E, it's shifted to the right 1, and it's also reflected and compressed. So let's look and see if one of them gives it away with shifted right 1. Number 6 is the only one where it starts shifted to the right 1. So this is going to be our E, which leaves C for number 5. All right, now let's look at some of these regular ones. So if you look at B, it's shifted to the right 1. All right, so which one starts 1 to the right? Just number 3? Okay, number 3 is B. D, it's got the minus 1 with it and the minus 1 afterwards. So it's going to go right 1 and down 1, which looks like number 7. E is done. F, you have a stretch of 2, and it's also shifted up 1. So number 9 is the only one that starts up 1, and it is stretched by a factor of 2. So that one is F. G, it's going to go left 1 and up 1, which goes with 8. H, that one's just going up 1, which leaves us with I, a left shift of 1. That was fun. That was fun. It was like a game. Oh my gosh, it's like math is a game.